organization to give us the possibility to show TSE Troller on this platform. My name is Mike Nielsen. I'm the CEO of the company TSE Troller, and TSE Troller is a family-owned company which celebrated last year the 60 years anniversary, and we are specialized for the production of coating equipment, pre-metered coating equipment. And this special coating equipment was developed in early beginnings in the 60s. And at that time, TSE Troller could produce such die heads for the photographic industry. And TSE Troller learned a lot at that time for in this industry, in this photographic industry, how to manufacture such coating equipment precise, and also how to create a good design to spread the fluid in a special or in a certain width of the die. Today we have 30 employees in Murgenthal. This is in the central of Switzerland, near Olten, between Olten and Langenthal, and we can make almost everything in our own production facility. So we have the designing team and also the manufacturing in-house, so that we can produce such for our die heads in-house. This is an overview of the coating methods in the pre-metered coating sectors. So Harold, he will explain more in detail certain methods of them to you. But as you can see here, there is a whole range of such die heads. And when it comes to a project for a production line or for a pilot line, we work together with machine builders worldwide. So we have machine builders which then are responsible to manufacture the complete surrounding, so that we can concentrate on this coating tool. Today we serve 3 different market fields with our die heads. We have on the left side here the paper industry, thermal paper, for example, or coating inkjet paper are some main products which are coated with our die heads. Then the converting industry, so coating adhesive material on a foil, for example, or medical, create medical products with such die heads is in the converting industry. And then we have the electronic market field, for example, lithium-ion batteries and fuel cells. So we have different market fields, and the electronic field is for sure the one which grows the most in the last years. Now, our customers, they have different stages they work in. For example, they start by developing a fluid, and when they mix that fluid, they try to coat it with such a tool like here with a blade coater. But the disadvantage of this coating is that you cannot scale this process. So you can check if the coating works, but it's not good to scale up the production with such a tool. Therefore, we have developed a so-called table coater, slot die, which coats on a sheet So then you can make some first principle trials with this table coat tool. So this is the product we have here in-house to offer customer trials for a first trial at our place, but we also sell this table coater as a whole unit to customers which are interested to develop new fluids or make first feasibility trials in-house. Then the next step is usually to do first roll-to-roll trials on a lab coater or in a pilot line. And of course, at the end, our customers, they produce in a full production line. And for these 3 different steps, we have also coating equipment which can be rented out to give customers the opportunity to check if such a pre-metered coating process would work in their fabrication. So here for the first step, this table coater, you can see here how that in principle works with a slot die coats a movable sheet, and this is a very easy coating process, can be done in a short time without a lot of efforts. So we do not need more than 100 milliliter of fluid, and a half day or 1 day in a half day or 1 day, you can learn a lot about this coating process and check if that would work for your coating task. Then when it comes to a further step, we have a whole range of coating equipment which we rent out. Here you can see the coating width. So it starts with 150 millimeter and ends with 1700 millimeter. Single layer, also double layer coating is possible, and different application methods like slot bead or tension web coating or curtain coating method is possible. So if you have such idea to coat samples with maybe an existing line, get in touch with us, then we can check if we can rent out equipment for a trial at your place, for example. Until today, we have done more than 80 die heads for the battery and the full cell application. So this is already a big number, and when you see this graph, you can see it growed at the last year's very high. So at the moment, we see almost an explosion in Europe for such die equipment. We do not have applications in that field in Asia. So all die heads we sold until today are sold in Europe or in the US. Okay, so that was my part, the first introduction. Now we switch to Harold. Harold will go now more in the technical details and explain you some background behind the coating.
Okay, perfect. Thank you, Mike. And thank you, Priscilla, as well, for organizing that, or for managing the 2 people at the same time, more or less. I hope you can see everything right now. So before we start going into the say details of slot coating in the battery or for battery applications, I wanted to show you a short video of a paper application coating on cardboard The die itself is almost 4.5 meters wide. It's a 2-layer application. So we have filled the first layer at the beginning. So there was coating color coming out, and now they are filling the second layer. The coating color is coming from the center. We have one feed port in the center, and it takes a few seconds until the curtain is stable. It was on the very first startup, so there was still some water and so on from the first trials, but that's not what I wanted to show you. It's just to see here. This is a liquid sheet of a color falling down on a height of like 25 centimeters or so. And now the die, as the curtain is stable, the die is moved upwards and then moved over. The web is already running under that pan. We will see it in a second. So the curtain is moving, and now it falls onto the sheet, and now you see the paper running there. It's an overboard application, so there is some liquid which will be collected in a pan underneath the die, which is not typical for battery applications or so. But this is just to show you how a multi-layer curtain die runs in a production environment. So that brings me to my short outline of the talk. I will go first introduce the pre-metered coating methods and especially slot coating with that. I will explain a bit about the internal die distribution geometry and the mechanical precision or manufacturing requirements, and then give you some advantages of these dies, and we'll take also a short journey into multi-layer coating, which is growing also in the battery industry, or the requests are growing in the battery industry, and we'll give you some examples of that. Coating, we typically distinguish between two families. One is called self-metered, everywhere where you apply too much fluid onto a substrate, and you have a metering device like a rod or like a blade, or here in this case it would be an air knife or a nip between two rollers, which is adjusting the amount of fluid. So this is called self-metered. This is not what we do. We are only focusing on the pre-metered coating methods. Pre-metered means you're calculating the flow rate which you need to apply a certain thickness at a certain width and speed. And as long as you control the flow rate, the process will be pretty uniform, pretty constant over time. It's a closed system, of course, and even if you have changes in the formulation, changes in the rheologic behavior or in the viscosity behavior of the fluids, as long as you control the flow rate, it will be, say, the result will be as expected. There is one advantage with pre-metered. You can also use or coat reactive materials, so multi-component materials, for example, a main fluid and cross-linker or a binder, which you inject right before you go into the die, mix it in the line, and then the fluid has the same properties all over the time. Last but not least, you can coat multiple layers at the same coating run. Pre-metered coating methods are very precise in both down web and cross web direction. In down web, it's easy to calculate, so that height in microns, for example, is calculated by the flow rate per unit width divided by the speed, or in other words, the flow rate is just the height of the layer to be coated times the speed. The uniformity in crossweb direction is basically determined by the design and the use of the coating die. Depends on the fluid properties of your coating liquid, operating conditions, and the geometry of the die internals, as well as the manufacturing degree of your tool. And this is something we will go a bit deeper later. This is the same slide Mike has already shown. In the battery industry or battery and fuel cell applications, we typically see single layer slot coating, maybe double layer slot coating, and sometimes also a slot die in the tangent web mode where you coat on unsupported web between rollers. What is also very important is the dosing system. The fluid delivery must be free of any pulsations, otherwise you will see a variation in the coating thickness or the coat weight in machine direction. This is clear when you pump or what you pump into the die comes 100% out of the die and goes onto the web, and when you pump pulsations into the die, you will see that height variation. Slot coating has a pretty large application range, so you can go from rather slow to pretty high speeds. You can do pretty low thickness, and the viscosity range is quite large. However, this is just giving you an order of magnitude. And the second comment is be careful when you want to combine the extreme values. So the highest speed, highest viscosity, and the lowest thickness will not work. Why is slot coating attractive? I said it's a pre-metered coating method, so high uniformity. You can do some multi-layer or have some multi-layer capability. You can coat aqueous and organic solvents and also 100% systems without any solvents. You can coat rather low thicknesses at low speeds, viscosity range, and what was mentioned by Mike already, it's a scalable process from narrow to wide applications. So the settings you find on your R&D coater or on your pilot line, they can be transferred onto your production line as well. Here are a few applications, traditional applications like adhesives, inkjet, and so on. Photographic emulsions was mentioned by Mike already. More recent applications, lithium-ion batteries, fuel cells, then also flexible electronics or barrier coatings for flexible electronics, and then transdermal patches, membranes, and things like this are more recent. The slot coating process in principle on a roll-to-roll machine looks like this. So we have rigid rollers where the substrate is going around in order to have a good wrap. And then the coating die itself ideally is installed in a 8 o'clock position or 7:30 as here. But of course, there are restrictions, there are constraints on the machine sometimes. Basically, the position of the slot die is not important to the process because the gravity forces they have, or the impact of the gravity forces is too small, so you can select the position where you want. However, the 8 o'clock position or 7:30 position is ideal in terms of purging air on the filling process and also the access to the slot. Slot coating process looks like this basically. So we have the coating die here with the distribution chamber, the feed slot. We have the two lips, upstream and downstream lip. and we have the so-called coating bead, so the flow field between the lips and the substrate. The substrate is running, the coating die typically is stationary, and we have the film forming meniscus here and the wetting meniscus on the back side. And you see here there are a few pressure indications, and you will see what that means in a minute. Here is a coating window, so we have web speed down here and vacuum pressure, which would be the upstream air pressure. But we could also replace that by flow rate. Then the pictures looks exactly the same. And you see, as long as you're within this coating window, your coating is free of defects. You have a stable and uniform coating. When you're going out, depending on which location you're going out, you have maybe air entrainment, or maybe you have defects like this, lines in machine direction, or sometimes also crossweb direction. Here you see what happens when you keep the speed and the distance between the die and the substrate constant. It's a battery electrode coating onto aluminum foil. We started with very low flow rate here, so you see we are just applying a few droplets. And then as you increase the flow rate, these droplets start to combine to cross lines. Sometimes we see nice pictures. And if you would keep the flow rate constant, these pictures or these patterns would remain pretty constant. And then there is a transition where you see just some open spots before you have a constant or a nice uniform coating. And this is from a practical trial from an installation startup, but you can see this in the theory as well. Here you see the flow zones in the coating bead. Again, here are the pressure indications again, and a picture which is unfortunately in the opposite direction. So here the web runs to the right, here it runs to the left. But this is just to explain the definitions again. And here you see, for example, this red line, the dashed line. This shows a bad position of the dynamic wetting line, because then you have air entrainment from the backside. You can get air bubbles between the liquid and the substrate, and then you have a bad coating result. So the steady state condition is when you have an equilibrium in the sum of all forces in this flow field, and that means that if you have like ambient condition upstream and downstream, that the delta P between these is 0, and that's the reason why you can do something with a vacuum box. Maybe you have seen a vacuum box was installed on that sketch, and I will show that now here as well. So here are the lips again. Liquid is coming out here, and this is a nice steady state condition. So we have the coating gap there, the wet thickness here, and the vacuum box would be a chamber installed upstream of the coating bead, which is reducing the ambient pressure here. In other words, that's increasing the pressure drop between here and there. And then you have more freedom with the liquid pressures inside the flow field. And Dr. Ruszak, he has found the so-called viscocapillary model, which helps to explain what's going on in the flow field. This curve here shows the transition between the unstable condition and the stable condition. In the diagram, we see here the dimensionless gap, or the gap ratio between the coating gap and the wet thickness. So the coating gap here and the wet thickness. And here you see the capillary number. The capillary number is like the Reynolds number, for example, in the flow mechanics or fluid mechanics is a comparison between different forces. The capillary number compares viscous forces with speed, or in other words, inertia forces and surface tension forces. And what you like to do is you would like to increase the coating gap, but according to this diagram, it's not allowed for each capillary number to use a large ratio. So, for example, if you have a ratio of 2, the capillary number, the referring capillary number is quite low, and when you calculate the capillary number, and this is maybe somewhere here, then you have to decrease the coating gap. And with vacuum box, you can shift the transition line towards higher gap ratios. So there are a few variables which are influencing the coating quality. First is the coating liquid, of course. The viscosity is typically shear depending, has a complex behavior, and we will see that in a minute. The applicator device itself, so the coating method, is also important there, and some other areas in the machine. Viscosity, as I said, is not a number, it's a behavior, and we typically look for the viscosity over shear rate. And in a double log diagram, typically you can find a curve like this. So you have a low shear plateau, then a certain critical shear rate when the shear thinning behavior starts. And at a certain point, sometimes it's running into a high shear plateau. In some cases, or depending on the measurement range, you don't see the plateaus, but this is a basic behavior, and we would like to see all the measurement data of your liquids because we experience different shear rate levels at different locations in the coating die. You can imagine in the metering slots, the shear rate is much higher than in the distribution cavity, for example, or the feed line. The ideal coating head, this is a kind of a wish list, which is not complete, but it's already long enough, or maybe too long. But of course, you want to achieve a certain uniformity in cross-web direction. You want to cover a certain range of different applications, physical fluid properties, coat weights, coating speeds. Then you have to, or you have some wishes for easy handling, assembling, dismantling. Sometimes you want to change the coating width, or pretty often you want to change that. Cleaning must be an easy task, and if you are running multi-component systems, you want to keep short residence times inside the die. So this is a long list, and of course, not all the parameters are important for all dies. For pilot or R&D dies, it's more the flexibility which a die can offer, which is important. And the possibility, for example, to change lip geometry, maybe a cavity geometry, and so on. And for production dies, especially in the wide applications for adhesives, paper, where the dies are 2 meters wide, 4 meters wide or so, you don't want to disassemble the die for cleaning. So cleaning in place on the machine is maybe the most important parameter on this, beside the cross-web uniformity, which you would like to achieve. That brings us to the internal geometry. So there are different possibilities to create this internal geometry. This picture here shows either a die which is fed from the side or one half of a center fed. It doesn't matter. It's valid for both possibilities. Basic idea of this here is that the pressure drop in the cavity in crossweb direction is much smaller compared to the pressure drop going through the slot, and this creates or this allows you to apply the film in a pretty decent way. The crossweb uniformity typically is not bad. However, if you have pigment loaded fluids, especially here in the edge region, there is not enough wall shear stress to move the pigments. The wall shear stress is basically the force close to the wall, which is moving the pigments. And if the pigments are not pushed to move, then they start to settle down and they agglomerate in this region. And this layer is growing and growing and growing. And therefore, the solution would be to use so-called coat hanger design. The cavity is smaller in the middle already and is, say, going down to a smaller cross-section towards the edge or towards the end. And due to the smaller cross-section, you maybe see some pressure drop in crossweb direction, of course, depending on the rheology behavior of the fluid. But this can be calculated and this can be compensated by, for example, changing the length of the slot. So here at the end, the flow resistance going through the slot is smaller than this. And the difference is exactly the pressure drop in the cavity. Of course, such a system is perfect in the uniformity, but unfortunately, it's not allowing a large range of different products. And this is why we typically combine this coat hanger design, first cavity and first slot, with a second cavity and a second slot. Again, this is either a side fed die or one half of a center fed die. But you see the cross section here. So we have both cavities and the two slots. And with that, we achieve a good self-cleaning behavior combined with an excellent crossweb uniformity over a pretty large range of different applications. When you compare the different possibilities here, single cavity coat hanger and the dual cavity, we have in the diagram here the different application points. This is the say design condition there, and performance of the die means how close are we at a perfect uniformity in crossweb direction. With the single cavity, we are really up to the 100%. But if you move away a little bit from that optimum point here, the performance is dropping significantly. And with a dual cavity design, it's much more robust, and we can really achieve a good uniformity for a lot of different products on the same die. Here you see how the distribution system looks like. We have in total maybe about 13, 14 parameters which we define for the dies, especially for production dies. That brings me already to the manufacturing precision. There is a relation between flow rate and pressure drop, which you see here. And the slot height here is in the third power, and that hurts us the most, because when we're dealing with the variation of the specific flow rate, the factor of 3 is in front of the variation of the slot height. That's the first bad thing. And the second bad thing is we're talking about small numbers here. All the other numbers are typically rather large. So the main impact is coming from the uniformity of the slot. And this is regardless which kind of distribution system is installed in the die. There are also other distribution systems available compared to what I've shown, but the mechanical precision of the exit slot, this is very strongly influencing the uniformity in cross-web direction. What we can say clearly is the lower the coated thickness shall be, the smaller the slot height will be. So it's more sensitive then for variations. And if you do the internal distribution system in a good way, so the theoretical uniformity is quite good, the impact of the mechanical precision is much higher than the flow distribution inside the die. And typically all surfaces with fluid contact are highly polished in order to avoid settlement of the particles. Here you see an example of such a coating die. This is a coating die for an R&D die for the paper industry with pretty large flow rates. But you see the coat hanger here, first slot, the second cavity, and the second slot there. And since not everyone needs the same high precision, we have, say, a table of different precision levels which we offer. And then we can find the best compromise between requirement or between performance and cost. Here is an example shown. Here you see the slot height, and this is the cross profile. And the parameter here is the slot uniformity or the variation in the slot. And as one example, for a 300 micron slot, the variation of plus minus 1 micron causes a cross profile of plus minus 1%. And this is without the impact to the rheology, so it might even be worse. What does that mean in the reality? I did a calculation here just to show you an example. This is for two battery slurries of different charges or different formulations. You see this rheogram here. This is calculated for a die almost half a meter wide, 4.5 meters speed, and almost 120 GSM dry coat weight. And the graph for the distribution, again, this is only 1/2 of the center fed die. So you see this is the center line where the feed port is. So it's going just to one side. Here you see two types of lines. The bold lines, they are showing the theoretical profile given by the rheology, by the flow rates, and by the geometry inside the die. And the two dashed lines, they are reflecting the mechanical precision or the impact of the mechanical precision. So you see here for one slurry, we're about 5.3% deviation, total deviation with single A precision. And then we can go through the different other precision levels. And with a 4A precision, we're down to 1.1%. The flow profile itself is exactly the same as with a single A, but the impact of the mechanics is much, much less. And this is, at the end, the benefit which you can receive with a high precision die. Here you see a die plate which is used for chemically reactive materials. So at the end, the coat hanger is very, very small. It's just in the order of 2 millimeters or so. Really small in order to keep the wall shear stress above a certain level. And with that, you can reach the different advantages. I'm not going through all this, but I think we touched more or less everything. Now, just want to go briefly into multi-layer coating. Why is that attractive? You can optimize the process and also the product. So you can introduce layers which are optimizing the process and maybe also the product. And some of the layers are only for the product. One of the questions which is asked mostly is, these liquids are not mixing. And here is an example from thermopaper application. Both liquids are basically the same, only here we used some color. And you see really a very sharp line between the two layers. The curtain dye is above here, and I was just holding a cardboard into the curtain. Nothing fancy, nothing sophisticated, just to collect the fluid. And you see, even when it's flowing down here, there is still this sharp separation line. This is an example from a battery application where they used, that was at KIT, where they used different pigment shapes, spherical and flake type. This was just an example to show how it could look like, and it was done a couple of years ago for paper applications. Here you see it's almost 8 years ago now. What are the challenges for multi-layer coating? Definitely intermittent coating, if that's needed, would be a challenge. Intermittent coating could be over full width or combined with lane coating as here. Then what could also be a challenge is the very high coat weight, maybe, which has to go through the flotation dryer if you're running with a 2-layer application or a 3-layer application. Here you can see a few examples. Single layer, continuous coating, lane coating there, intermittent coating here. And here you see a few more. Finally, this is a 2-layer dye also used for battery slurries, which is in production now. Well, this is in an R&D facility, but it's in continuous operation. Here you see this is from BMW on one of their pilot lines. It's an official picture from their website. That brings me to the summary. I think we can jump through and take or go through and take the most important things. I hope I could give you some introduction into the background of slot die process and the die design. It is not trivial, that's clear. You have to define performance criteria thoroughly. You have to think about the coating fluids or the slurries. Sometimes the rheological behavior is quite complex with time-depending behavior. Thixotropy is one point, or sometimes you have yield stresses. Sometimes you have forming of a structure at low shear rates, things like this. That's something which we have a lot of experience with, and we can help our customers with our experience, especially in this field, how to do rheology measurements and so on, or to do some additional measurements maybe. It's good when you do the die design that you have some theoretical knowledge and practical experience as well. It's very helpful, and it needs the optimization process. It needs really a dialogue between the die manufacturer, us for example, and the end user to understand what is possible and what is available, and what kind of information is necessary to achieve all that. The precision of the slot die manufacturing influences the die performance in a high degree. I could show that to you, I think. And the precise manufacturing can be very attractive and beneficial for different reasons, of course. Short introduction into multi-layer coating. It becomes more and more attractive because of different aspects. The multi-layer structures, they help to improve or to optimize the performance of the product, as well as the economics of the process. Multi-layer coating methods are pretty well known. We are doing this since the late 1960s. The methods, pre-metered coating methods, they require thorough planning and preparation for the implementation. But with our over 60 years experience, we can really support you as good as possible. And yeah, that's what we talked about already. The process itself is scalable from narrow to wide applications. Very often in R&D, the first trials are done with maybe 5 centimeters only, and in production they are sometimes talking about 2 meters or even more. The drying process of a multi-layer structure is also an important topic. That's something you have to investigate. As Mike already mentioned, we have single layer and multi-layer slot dies available for trials on both sheet-to-sheet coaters and also on roll-to-roll machines. So thanking you for your attention. Hopefully it was not too much in a short time. And if you have any questions later on, you can also drop me an email with your questions, and I get back to you as soon as I can. Thank you very much.
Thank you, Harald, and thank you, Mike, for the presentation. So I'll open the floor to questions. You can write them in the chat or just raise your hand or directly talk. So I might start with one, maybe, so just to ice break a bit. And so my question is more on the future plan about coating in battery industry. So we know that the European Union and generally manufacturing in Europe is moving away from solvent based coating, going towards or dry coating or water-based coating. So what it is the position of TSE with regard to this change in the technology?
We are open to more or less everything. We have some projects in the field of solid state batteries already. For us, it's basically no difference if you coat solvent-based or water-based solutions. The dyes are working basically for both fields.
You just have to tune it with respect to the rheology and...
Exactly. For us, the rheology is the most important parameter, including the flow rates or the operating conditions. And then we adapt the internal die design and maybe also the lip design on the outside according to the needs.
Okay, and is it also something, because I think you need also to control humidity and all the other stuff, but this is done in the chamber where your die lies, right? So
exactly, that's typically done either in a chamber around the machine or in the entire room.
But about dry coating instead, this is completely different, right? So
well, the requirement for the say room conditions, I think they are maybe not so different compared to conventional electrode coating. As at the end, when we talk about the relative humidity in the rooms, we have say pretty low dew point in both areas, in solvent coating, solvent and water-based coating, but also for the solid state coating.
okay. So thank you. And it was very nice to see that also BMW is using your die slot for.
BMW, well, this is a little bit unfortunate because the industry is quite sensitive to show references, to show names. BMW has this picture on their own website, so we are allowed to use it. And they informed us that we can use it, and therefore we are happy and grateful that we have this reference which we can show. But you can be sure that some other car manufacturers also are working with our dies.
Good. So did they motivate maybe some of people in the room to have a question?
Yeah, maybe it takes some while, and again, I can encourage you. I want to encourage you to send an email if you have some specific questions.
Sure, but yeah, so I really believe that you will have a lot of success with this ramping up of the battery manufacturing in Europe, and also about all what Europe is investing also on fuel cell and hydrogen. So you are in the right business, I think.
Yeah. And for us, it's not only this industry which is booming.
Sure.
We have some others as well. Also, some are related to COVID.
Okay.
Yeah.
Okay. So if no any other question, I'll close here the meeting. And as Harald already said, please feel free to drop them an email if you have specific question, or if you want to say something to them. And so if this is all from this Battery Tuesday, we will see each other next month with I'll just check it again. So the 2 of August with the LIBA Service 24. And yes, so iBAT will send you some invitation for other events, and please check the website for keeping track of all the events that will go on for the rest of the 2022. So thank you, everybody. Have a good afternoon, and see you in a month.
Okay, thank you very much, and bye-bye to everyone.
Bye.